In this video, I would like to show you the frequency function. What is the frequency function? First of all, we have got, as usually in this series, we have got a stable and linear time invariant system. The input feeding, the input signal, is a sinusoidal signal, and the response of the signal is also a sinusoidal signal at a steady state. So we are speaking about the steady state behavior of the system. But now I would like to show you a technique how to connect the input signal, the U, and the output signal Y. How to connect the amplitude and the phase. And don't forget that the term omega t are the same in the input and in the output, but the amplitude and the phase are changing. They are changing from frequency to frequency. So if we modify the value of omega, the output amplitude and the output phase will be changed if I compare it to the input amplitude and the input phase. We can do a very simple measurement. So it's a kind of measurement which I would like to show you now. It's a measurement technique. So first of all, we are going to set the value of U hat and alpha. So we can set it to a constant value. For example, let's say U hat is 1 and the alpha is 0 degree for every value of the frequency, and so on. There are many measurements. Next, we are going to set the value of the frequency in a range, let's say from 0, the value of 1, and so on until infinity. So a very big value. And from frequency to frequency, we are going to do a measurement. For example, for 0 frequency, we are going to get y1 beta 1. Let's just say some value. For the value of omega equal to 1 in the second row, we are going to get another value, y2 and beta 2, and so on. So it's a table of the values of the output. We measure the output amplitude and output angle as the function of the omega. So these values are depending on omega. I put two other columns. The first one is k and the second is phi. The k we are going to get as follows. We are going to divide the output amplitude and the input amplitude. This is the value here. This is the value here. So these are not zeros, so it's not a good notation now. So we are going to get k1 here and k12 here. For example, k1 is equal to y1 divided by 1. k2 is equal to y2 over 1, because u hat is always 1 in this case. The second is phi. We are going to get phi as the difference of the output angle and the input angle. So beta minus alpha. So it gives us a value for phi 1, another value for phi 2, and so on. But it is very important to recognize that k and phi are depending on the value of the frequency. So let's say k is the function of omega, phi is also the function of omega. So the first one is a kind of amplitude function. We are going to use it, amplitude function. The second is the phi is the phase function. And from these notations, we can imagine that if we prepare a so-called frequency function, and this frequency function is a complex function of omega, we can say that the complex amplitude of the output, so y hat e to the power of j beta over u hat e to the power of j alpha, we are going to get y hat over u hat multiplied by e to the power of j beta minus alpha. So the first term is exactly the k function, and here we get exactly the phi function. So finally, we are going to get a complex function, and it is called the frequency function, and it is denoted by w bar of omega, which we can get as the division of the output complex amplitude and the input complex amplitude. That is, I write it to here, wj omega is y bar hat over u bar and hat. So this is the real definition of the frequency function. So finally, the frequency function wj omega, it characterizes the system. It means that if we have got an input function, and if we know the frequency function, we can obtain the output function. But how? I would like to show you it at the very end of this lecture. So now I can put this complex function to the box. Let's say wj omega. Wj omega is noun. Let's say it is noun. Noun from measurement or noun from somewhere, and somewhere means that some techniques which I am going to show you in some lectures later. But let's say we know wj omega. How to use it? How to use it? The first, we have to put the input to the complex plane. This is the technique that we have mentioned in the last lecture. If we know wj omega, which is y bar hat over u bar hat, and from this we can obtain y bar hat, so that is the complex amplitude of the output function. This will be equal to w bar, because this is a complex number, multiplied by u bar and hat. So now we can see that omega is in the time function. We have not used omega yet, but now we have got a given value for omega, and this omega is we are going to put to the function, to the frequency function omega, and this frequency function is going to say us how this system is working at the frequency of the feeding. Okay, so if we put omega to wj omega, we are going to get here a complex number. So this is a complex number. This one, the input, is also a complex number. Next, we are going to multiply two complex numbers, and here we will have a complex number with a given amplitude and a given phase. And from this very end point, we can have the amplitude of the output function, and we will have the phase of the output function, and finally we can get omega from the input. So this will be the response of the system at the given frequency omega of the feeding function. So once more, I said Wj omega has the same notation as W omega, but it should be a complex number. This is why I use a bar hat. So this is the same notation, but in the future we are going to use mainly the first one. So if we have got y bar hat, this is equal to w bar and u bar hat. It means the following. From the definition of y bar, we can say that it is equal to k, which is the function of omega, e to the power of j phi omega. It is multiplied by u bar and e to the power of j alpha. So at the end, we will have a complex number, which has the amplitude of k omega u hat. So this will be the amplitude of the output function, and e to the power of j phi omega plus alpha. This will be the value of beta, and this is y hat. So this is how the transfer function is working. In the next videos, I am going to show you some examples how to use it in practice. One last remark. In the lectures, I am going to use W for this, but in many books you can find H for that. So H, J omega, or W, J omega, doesn't matter, they are the same, but in some books the author used the H, some author of the books use W. In this lecture notes, in this lecture series, I am going to use the notation of W.